Camera.
Multivariable calculus, group project 1, vector equations and river navigation. Or they'd rather be home. Charlotte and Christian have misread their maps while hiking. After walking around aimlessly for 3 hours, they finally spot a ranger station.
You're not walking around aimlessly.
They finally spot a ranger station. It is on the opposite side of a river, whose straight banks are 150 feet apart. There was a small motorboat tied to a dock with a call box on their side of the river. They used that call box to phone the ranger station. Ranger Hernandez answers,
"This is Ranger Hernandez speaking. How may I help you?"
My friend and I are lost, and we're hoping you can give us some guidance.
"Sure, if you want, you can use the boat at your dock to get to my side of the river, and when you get here, I'll have someone give you a ride to your destination in our all-terrain vehicle."
Yahoo! I'll start the boat right now.
I heard that, but not so fast. The boat has a broken rudder, so you'll have to head out in a fixed direction, and do so in such a way that the boat's speed and direction, combined with the river current, will guide you right to our dock.
Mr. Hernandez. Okay, but if we're slightly off, I presume we can tap the boat where it lands and walk to the station, right?
That would be extremely risky. Our side of the river is infested with venomous snakes. If the boat lands either side of the dock, you'll be in a very dangerous situation.
Wow. Can you tell us how fast the boat goes and how fast the current is?
The boat travels at a constant speed of 5 feet per second in still water. The current situation is a bit complicated. The river flows parallel to its banks, and the current speed at any point x feet from either bank is 6 times I over 150 x feet per second.
Okay, thank you, Hernandez, for your help. We'll give it a try and do our best. Goodbye.
Goodbye, and please be careful.
This predicament calls for some serious thinking.
That's for sure. Let's see if there's anything in my backpack that might help.
Christian reaches into his backpack and pulls out his binoculars.
Okay, you take the boat controls while I look at the dock through these binoculars. And then I'll give you the directions to steer the boat so that way we're always heading straight towards the dock.
You must be dehydrated. The rudder is broken. We can't steer the boat, remember?
Oops, sorry, my bad.
Christian thinks for a while, then in desperation says, with gusto and confidence,
Let's just be bold and head out in a direction that seems to make the most sense.
What do you mean seems to make the most sense? Are you proposing another one of your let's just experiment ploys?
Sure, what's wrong with that?
Duh! There are venomous snakes over there. If we wind up any distance either side of the dock, we'll be in a real mess.
I'm a physics major. How else am I supposed to solve problems like this one?
Are you skipping a line?
Wait, back that.
Wait, did I skip a line?
Can we make that a little more wimpy? Let's say, Winter's voice. So let's go back to Charlotte.
Right. Oh no, I didn't. Okay.
Duh.
Duh! There are venomous snakes over there. If we wind up any distance either side of the dock, we'll be in a real mess.
But I'm just a physics major. How else am I supposed to solve problems like this one?
Oh, come on, Christian! We're taking multivariable calculus. We can do better than just trying experiments. Don't be a fizzle sis, be a real man. The math and help me calculate exactly at what angle of bank we should direct the boat.
I suppose you're right. And I agree that we'd likely get the job done best if we were working together.
and so, class, here are our tasks. Student class today in about 15 minutes. Form the groups in which you will work. Each group will consist of 3 or 4 people. Based on careful thinking about the river current, produce a rough sketch of the path that the boat will follow if Charlotte and Christian head out at the correct angle. Due Friday, September 20th in class, give an arbitrary angular heading theta. Find a vector equation for s vector of t, the position of the boat at time t, where t is measured in seconds. Determine the angle theta from the riverbank that Charlotte and Christian should direct the boat so that they will arrive at the ranger station dock. How much time will your journey take? Using the angle in part B, simplify s vector of t with any constants rounded to 4 decimal places. Then produce an accurate sketch of the path the boat will follow. Hint 1. The strategy for solving this problem can be divided into 4 stages. 1. Set up an appropriate coordinate system. Suggestion. Align the positive y-axis with the direction of the river current and call this direction north. WOLOG, or W-O-L-O-G, locate the...
That means without loss of generality.
Okay. Without loss of generality, locate the dock by the ranger station on the east side of the river and set location 00 to be at the dock by Charlotte and Christian. The angle theta would then probably best be measured from the negative y-axis. 2. Assume the boat is directed at an angle of theta. Get v vector t, the velocity of the boat at time t. Caution, be sure you calculate velocity at time t measured in seconds and not big V vector of x, the velocity of the boat when it is displaced x feet from the riverbank. To get velocity, first determine big V vector of x, then get an equation that relates x to t. In 2 or 5 points, give an expression for big V of x. Gives an expression and shows how to derive velocity.
To get that hint, you gotta ask me.
Okay.
And you take away 5 points.
Okay. Compute s vector of t, the position of the boat at time t, by integrating v vector of t. If theta is set properly, the boat will eventually arrive at the dock by the ranger station. Designate the arrival time by t asterisk. Then note that s vector of 0 equals 0, 0, and s vector of t asterisk equals 150, 0. Making judicious use of this information will allow you to calculate both the correct value of theta as well as the time the journey takes.
Cut. Okay, that's a wrap.